We're gonna find the volume generated by this area, all this area, spinning around or revolved around y equals 3. Two different methods, okay? So we're gonna do this first. We're gonna make this is y equals 3, and then we're gonna make the integration from this point to this point, from x equals -2 to x equals 3, because it's the intersection in this part. So if we use the disk method, it's like if we make this disk over here. Okay, this is not the perfect disk, but this is the radius and this is the little radius. Let me show you this again. So the big radius is going to be red, so this is a big radius, while the little radius is this blue. So again, the big radius in here is this, the little radius is this one. So if we identify this as the key element to solve the problem, we can do this. So the volume is the integral from -2 to 3, because this is -2, this is 3, pi, and this is the line around where the area is revolving. So this, in this case, this r is this 3 minus this y. So this is 3 minus this y, but this y is x squared minus 6. So this is 3 minus x squared minus 6, and this goes square. So I need a bracket over here. So the little r, which is this, is only parentheses 3 minus, and this y is x. I close it, I square it, I make this bracket here, and this dx. So I'm gonna write it in a better way. So the volume is the integral from -2 to 3 pi, the big R square minus the little r square, dx. So r is 3 minus x squared minus 6, that's the big R. The little r is 3 minus x. Okay, let's go back. I'm gonna clean this to make this again. So this is my big R, correct? So this r is this number 3, because y is 3, minus this y, but this y is x squared minus 6, x squared minus 6, this goes in parentheses. The little r, this little r, this r equals 3 minus x, or this y, but this y is only x. So r then is 3 minus x squared minus 6, while r is 3 minus x. So let's go back here. This is pi, goes outside, -2 to 3, and the big R is 3 minus x squared minus 6. Okay, so this parenthesis closes this parenthesis, so this is a square, minus x minus, no, sorry, this is 3 minus x square. Okay, this bracket closes this bracket. Okay, let's see, this bracket closes this closes this closes that. Okay, our parentheses and brackets are correct, and this is the x. Why is the x? Because I'm moving. Okay, I'm moving these little discs. Okay, this is R, and this is dx. So bringing my calculator, what I'm gonna do is, okay, let's see the expression. This is pi, so this is, well, this is first pi integral in calculus from -2 to 3, and the big R, okay, parentheses, the big R is 3 minus another parenthesis is x squared minus 6. I close this parenthesis, I close the next one, this is square. Okay, I'm squaring from 3 minus the parenthesis minus another parenthesis 3 minus x. I'm closing here and I am squaring there, and I closing the next parenthesis, and I'm talking about x. So the answer here is 625 pi thirds. Okay, that's my answer. So the volume is 625 pi thirds. Okay, this was using the disk method. Okay, is a disk at every time, like this. Okay, and big R, little r, and it's like a donut. So now I'm gonna use the shell method. Let me clean everything here. So now using the shell method. In the shell method, I need to integrate differently because I have like a little cylinder here spinning around. So this is my R, this is my H, and this is the dy is the thickness. So now I'm integrating not this direction but this direction. Okay, so what I'm gonna do is establish first what I have, because from here to that part all I have is this cylinder, which is this this curve minus this other curve. But in this case I have this curve minus this curve. Sounds maybe weird because this is the same curve, right? But in terms of x, so if I have this is y equals x squared minus 6. In terms of x, if I say x equals something, let me tell you what is that. So I have y equals x squared minus 6. So y plus 6 equals x squared. So when I get this square root here, but this is plus and minus because it's one part this direction and the other part is this direction. So in this case is not a problem because it's this x minus this x. So for example, in this little part is x equals square root y plus 6, and this part is x equals y. So what I'm having in this little part is square root y plus 6 minus another y. Okay, this is the height for this part. But in this part is different because this is one part of the function, this is the other part. So I'm gonna clean it again. So I'm gonna establish first my limits. So this is y equals 3, this is y equals -2, this is y equals -6. So I'm gonna make an integration in this part and another integration in this part. So what I'm gonna do now is just writing and solving in the next page and solving with a calculator. So the volume is the integral number 1. Let's call this integral number 1 plus integral number 2. So this is integral number 1 and this is going to be integral number 2. So, and I need to declare what happened here. So let's see this again. So the first part is volume equals integral from -2 to 3, and I'm talking about 2 pi because this is a shell method, and the radius times the height times dy. So what radius here? Okay, so my radius is 3 minus y. That's my radius because I'm starting here and I'm subtracting this little y, right? So height in the first part is this y minus this other y. So this y is well, this x minus this x. So this x is square root y plus 6. This x equals y. So this is square root y plus 6 minus the other y. So this is my integration part in this little part. So now let's make in red the other part. So I'm integrating from -6 to -2, 2 pi r times h times dy. Okay, what is r? R is again this number 3 minus the y, and it doesn't matter if it's negative because to here is 0, but I'm adding here. So this is 3, and I'm adding this 2, and then adding this part. So r is 3 minus y again. So this is no, there is no change in here. What is changed is in this part, because this is x, and this is another x. What is this x? This x is square root y plus 6, and this x is negative square root y plus 6. So it's this minus this part. So h equals square root y plus 6 minus the next one, which is negative square root y plus 6. Okay, this in a very clean area is this part. The volume is from -2 to 3, 2 pi, 3 minus y, time, this is, you remember, this is 2 pi r h and the thickness. So this is 3y, and the other is square root y plus 6 minus y, close it, dy. So this is the upper part, plus from -6 to -2, 2 pi. My radius is again 3 minus y, but now my h is a little different, is square root y plus 6. You remember this part, this is a double negative here. So this is plus square root y plus 6, close it, dy. So this becomes twice the square root y plus 6, which makes sense because this distance, this is equal to this distance, so it's twice the same distance. So this distance again is equal to this, so it's twice only one distance. So that makes sense. So if I bring my calculator just to evaluate this, you want to make this. Okay, let's see it. Is 2 pi, in both cases is 2 pi, 2 pi integral, calculus integral from -2 to 3 times parenthesis, another parenthesis, the radius, which is 3 minus y. I'm closing this parenthesis, times the next parenthesis, which was square root y plus 6 minus y, because was the line. Close the parenthesis, close the other one, and I'm talking about y. Plus, well, this is not in this part, this plus another 2 pi times the integral, calculus integral, from negative 6 to negative 2. And again, my radius is 3 minus y. You remember it's a double parenthesis. I'm closing this parenthesis now, times another parenthesis, and you remember I'm entering now this part. Okay, 2 times y plus 6. So this is twice the square root y plus 6. And I'm closing this parenthesis, and I'm closing the next one, and I'm talking about y. And then my answer is 625 pi thirds. So this is, the volume is 625 pi thirds. So this was the shell method. The method before was the disk method. In both cases we get the same answer.